Good morning, everybody. We'd like to express our appreciation for you to jump in and listen to or participate in our webinar this morning. My name is Paul Stathis. Most of you know me. I run BICSI South Pacific organisation. We've been running a number of webinars courtesy of coronavirus lockdown since we can't run our physical seminars at the moment. Apologies for not running seminars in recent weeks. We've had some unfortunate dropouts out of some of our presenters, which is disappointing, but I'm delighted today that we have such an important topic on fire stopping. We've got our guest speaker, Rick Chan from Hilti, Australia. He's the non-structural leader in the fire area, which is an important position. Before we introduce Rick and lead him into the presentation, I'll just give you a little bit of background as to why this has been a topic. We have been discussing fire stopping for many, many years. We've had a number of physical presentations at our our seminars in the past. The feedback has been it's the most engaging, particularly when the building industry talks to us about it. The reason it's important is that we cannot escape the fact that we are under the auspices of the building code, the National Construction Code of Australia. There's also an equivalent for New Zealand, and every country has its own safety legislation for building areas. This not only applies to the structural integrity of a building, but also the services that go within it. So most of us involved in ICT infrastructure provide physical services, be it cabling or wireless networks or electrical or pathways and spaces, whatever the case is. There are times when we will encounter barriers to our designated pathways, and at times we need to put a penetration in these barriers because they're deemed as fire rating. That's not to say that we can't do it. The building legislation in every country allows us to do that. However, the important thing is we have an accountability, and I've sort of used the term of if you break it, you fix it. Then we are accountable for reinstating the integrity of that barrier. In fact, just a little bit of background, as many of you know, I'm on the committee that's rewriting the S008 and S009 cabling regulations for Australia. This has become a big issue, and we've spent many hours discussing the aspect of fire stopping. We've consulted with many subject matter experts in this particular space, and we will be talking about that down the track once the S009 regulations have been released in the next couple of months or so. But for the time being, we have been able to have lots of discussions with Hilti. They are experts in the field of fire stopping. Now, this is not a promotion for Hilti. This is the presentation of subject matter experts to guide us, pardon me, guide us as ICT infrastructure professionals to know what to do, how to do it, and to understand the consequences of our actions, which is a very important point. So we do look forward to this presentation. Just to give you a little more update on the information, this is a very lengthy, complex field. So we've broken up this topic into two presentations. So Rick will be speaking for an hour today, basically leading us through the principles and the guidelines for it. In 4 weeks' time, Rick will be presenting again on the 25th of August on the second part of the topic, which is basically air migration and fire stopping in healthcare and data center facilities, areas that are mission critical, but also subject to the issues of migration of air and particles and all sorts of areas in that space. So we'll do a considerable drill down into that particular space. So we'll invite you to participate in that. We also have another one coming back up on in a fortnight's time on Tuesday, the 11th of August. We have reached out to a lawyer and a safety specialist. Our intent is to have an interesting discussion, the difference between safe work method statements and job safety analysis, JSAs versus SWIMs. So for those of us in Australia, we're very familiar with this. The problem is in fact, most of us have no idea what the difference is. So we're bringing on a safety expert to explain it and a legal expert to explain the legal ramifications of all of that. So we'll get that information out to you as soon as we've got that locked in, and that'll be on the R&M GoToWebinar platform, but we'll let you know about that as it happens. So without going on any further, I'd like to now welcome Rick Chan to speak to us. He's the non-structural leader at Hilti Australia for fire stopping, and we'll listen with interest to your presentation, Rick.
Thank you, Paul. Paul, can you hear me well? It's all right?
You're fine. Yes, thank you.
Thank you. So let me also briefly introduce myself. Thank you so much, BICSI, and also all the attendants today for upcoming around an hour talking about fire stopping principle and guidelines for the ICT infrastructure. A bit of my profile. I worked in Hilti for around 9 years. I started from Hong Kong and then moved to China, and then I came to Australia around 2 years ago. Currently, I'm based in Sydney. So in all my 9 years in Hilti, actually, I on and off working in Firestop related topics, from engineering, product management, and also right now is more like on a team leader role, look after the non-structural team for Hilti. So Firestop is a complicated topics, I would say. So therefore, I also agree with Paul. Let's try to split to two parts of the presentation. Today, we are more talking about the basic principle, okay? Mainly surrounding Australia Building Code, NCC, okay? And also, how can we select it or decide the penetration as per the code requirement? To begin with, I want to show you first, what is the linkage between fire stopping? Yep, and also cableless. Okay. As Paul also already outlined a little bit, it is mandated by the building code in Australia. It is also when we have penetration, when we got a cable, need to go through certain rooms, we need to check the rooms. Is it a fire rated barrier? If it is the case, when we go through it, we need to do proper seal up. Paul used the point like break it and fix it. Okay, I would more think about, can we do proper design to design perfectly rather than break it and fix it. Okay, I hope that after the presentation today, you will know a bit more why we need to think through it. Okay, because if we just break it and fix it, it could happen that there's no solution. We can't find a compliant solution. So fire stopping is about when we have any surfaces crossing barrier. Okay, we need to fire stopping those penetration or opening. Okay, it is cross different trade, not only to cabling, but also related to plumbing or other services. Okay, so whenever we got an opening on the wall, if the wall is a fire-rated wall, we need to find a way to seal it. Make sure that the integrity of the barrier can be maintained. Yeah, and cabling is also quite special, because considering in terms of too many different variety of cable, too many potentially we got conduit, without conduit, big bundle cable, single cable. Those are the variation that we need to consider when we do proper fire stopping design. So I hope that I can also bring in certain cable management concept in part 2, when we jump on the mission critical facility about healthcare and data center. Because those building, we know that there's more requirement, more cables also. So we will reserve another slot in part 2, talk about air leakage concern, clean room requirement, etc., etc. Yeah. So, and I also want to emphasize that Firestop is about compliance. Okay, I also talking to a lot of building certifier in these 2 years in Australia. They all told me that fire stopping is the major defect they find in job site, due to a number of reasons. Okay, it is the time we should pay more attention to make sure that every opening we drill through the wall or pass through the floor, we are thinking about what solution we should apply to seal it up. So this is the agenda of today. We will just talk about the basic, what is fire stopping first, and then we will jump to some example, what is compartmentation. Personally, I quite like the third part about how to decide a proper penetration. I will use an example to talk you through what are the criteria we need to think about. Due to the internet, I think I would stop share my video, but I will share back in the Q&A section. So firstly, let's understand the basic of fire stopping and why it is necessary. Okay, good. To provide a more formal definition, fire stop system, if installed correctly, will help restore the rating of a floor or wall, as it is penetrated by an object or joints and resists the spread of smoke and fire. Fire stop is part of the life safety plan in the building structure. Life safety include air duct with damper, smoke and fire alarm, wire-rated glass, fire-rated door, sprinkler system, and etc. Well, consider how people realistically when a fire alarm sounds during a real fire scenario, people need time to safely evacuate from the building through the designated exit route, which are protected by the fire-rated wall and fire-rated barrier. Basically, it is the concept to buy time for people to escape from the building. And also, it is not surprisingly saying that different countries, they have their own code mandated, saying that fire stopping is need to be maintained. For example, Australia, we are following National Construction Code, or we also call it BCA, Building Code of Australia, and also for New Zealand, also New Zealand Building Regulation. Some more statistics, just to confirm the reality of fire and smoke risks. Actually, 3/4 of all fire deaths are caused by smoke inhalation. And approximately 57% of people killed in fire actually are not in the room of the fire origin, which means fire will spread. Okay, fire and smoke, they will spread from one place to another place. When it comes to visibility, in certain research, we find out 47% of survivors caught in a fire have said that they cannot see more than 4 meters. As we can see from the photo, in case of fire happen, that even a small opening and the smoke pass through, it will already reduce the visibility. When the people can't see it, they would have injuries and also causing damage and death. Finally, the reason of those figures and statistics, because actually smoke travel really fast. It can travel up to 40 to 130 meters per minute under the fire condition. So those data are coming from NFPA, National Fire Protection Association. They did comprehensive research to emphasize why it is important to have a proper fire stopping, prevent the fire and smoke spread through compartment. So a quick question, what is the leading killer in fire? Okay, so I think I also kind of indicate showing from the previous slide. We all know that it is about the smoke and the toxic gases. We are not only talking about the heat in case of fire, but also the smoke transfer. That's related to, even though we got a small data cable go through a wall, why we need to properly seal that opening. And in addition, the biggest threat to damaging communication and server equipment within the building is also about smoke and product of combustion. You can imagine that when we are working in certain high requirement project with a lot of communication cable and surface equipment, in case of a little bit of smoke leakage, it will already damage our equipment. To end up, we have significant cost in terms of replacing all those equipment and software, especially happening in data center. That's kind of a high requirement project. So more linked to a data center related, because we are in the ICT infrastructure industry. So I also did some research from NFPA. There's a number, 1,200 Aussie dollar per minute. It equal to also 17 million per day. This number reflects the average downtime cost of a data center if it has shut down due to accident. Basically, it is burning money down to not only minutes, but even a second. So there's a significant huge impact if there's any downtime happen in the data center. And another figure reflected that most of the non-home fire, close to 80%, beginning with electronic equipment. Because all the electronic equipment, they will generate heat when they operate. Okay, so those equipment actually they are the fire source in majority of the non-home fire. If we look into the project like a data center, they are full of electronic equipment and have extremely high downtime costs. So it is so important to have proper pacifier in those projects. Okay, let's jump to a holistic approach about what is fire protection as a whole. Because people may question, the building already got a sprinkler protected, already got suspension system, detection system, that little hole can live it. But it is definitely not true. A balanced approach to fire protection is achieved by utilizing three elements, also known as this fire protection triangle: detection, suspension, and containment. Detection device consists of smoke detector, heat detector, infrared flame detect device. Suspension system is talk about the sprinkler system, also as well as some dry chemical extinguishing system, like FM200, that sort of chemical extinguishing system. And finally, the third element known as containment. Okay, we talk about fire containment, the top part in the triangle. There's where that the fire-rated wall floor barrier come into place. Containment is not only about penetration fire stop, it is also linked to the wall and floor as the core element. But when there is any penetration go through, no matter any sizes, go through those fire-rated barrier, the integrity of the wall is destroyed. The opening must be properly fire stopped to extinguish the original integrity of the assembly. The biggest threat to damaging equipment and communication is smoke and the product of combustion, as I stated before. With just a few small holes in fire-rated assembly, smoke can already migrate through a building in a matter of minutes. It is essential that the firestop installation is done correctly. Firestop is a form of passive fire protection. Detection and suspension system are form of active fire system. Basically, both passive and active, we all need to be balanced and also be covered. When referring to sprinkler system, a common interesting question would be, can a fire overcome a sprinkler system? Of course, the answer is no, no way. Yeah, it can't overcome this. The sprinkler is not enough. That the reason is because many people do not realize that majority of the sprinkler system are not designed to extinguish a fire. They are simply designed to stop control it. Sprinkler systems are designed based upon the calculated fire area. If a fire rapidly spread beyond designed containment area due to improper fire stopping, for example, because there's a cable forgot to seal or haven't sealed properly, additional sprinkler head could be activated. It would dilute the intense volume of water supplied to the area of the original fire occurrence. And you can imagine that if there's a multiple zone sprinkler they activate, at the end of the water pressure may not be enough. So in addition to working in conjunction with the active system, containment fire stop will provide the critical life of defense. If the active means of fire protection went to malfunction. When come to similar mission critical facility like data center, there may be no water-based suspension system. However, those chemical-based suspension system like FM200 similar type also referred on proper fire stopping in order to help ensure the proper room pressurization. The room pressure need to be maintained. Make sure that the gas can be stay in that certain, and again is controlling the fire. As you can see that the Hilti point of view is pretty clear. We advocated a balancing approach to fire protection with multiple suspension and detection systems. None of them can cancel us, and they are equally important in this triangle. And more importantly, we have a very clear requirement. Fire-rated barrier played as critical role as suspension system or other system. They are all equally important from the building code. Next, we will jump on the concept about compartmentation. And having the chance, I will also briefly also mention about fire and smoke barrier. Because as we all know, we are talking about containment of the fire. So let's have a look of this slide. The concept of compartmentation is basically restricting the fire and smoke to a certain area of a building. As I outlined, it is also buy time for people to escape from the building. It is also protect the equipment, protect the facility inside the building. And now from the picture on the left-hand side, you can see that the fire-rated corridor, okay, the blue part, the fire-rated corridor. Actually, all the fire-rated walls surrounding the corridor is going to protect the people can escape from, go through the protected exits. And the code may also regulate between the room need to be have certain barrier. For example, as a normal residential project, basically all the interdependence wall, they are also fire-rated wall. So similar, also same for hotel. If you talk about data center and hospital, maybe the fire-rated wall won't be that straightforward, but it normally will also come in the architectural drawing. Several areas within a building structure cannot allow for fire and smoke spread. These are the critical areas that must properly fire stop in order to limit the fire and smoke risks to our telecom switching equipment. This illustration also showing the concept of both fire-rated wall, horizontal containment, and then the floor barrier, or we call the vertical containment. The right-hand side is about the vertical containment, prevent the fire spread through the floor. And basically all the high-rise building, the floor must be fire-rated. The number of fire-rated assembly, how many minutes rating, will depending upon the occupancy and the building type. And later, a few slides later, I will demonstrate how can we find out what is the actual rating requirement, FRL requirement from the Australia Building Code. Just a quick video to show you pacifier protection and compartmentation.
Typically, 5 minutes is all you get. Fire, and especially smoke, spread through a building much faster than most people think. Every year, about 3.8 million fires occur worldwide. While damage to assets is in the billions, the yearly death toll amounts to 5,000 persons. Much of this could have been prevented if correctly installed fire protection had been in place.
Architects, planners, engineers, and building owners are responsible for effective fire protection. Oftentimes, they do not realize that firestop is not an option. It's a clear legal requirement, and negligence or improper execution is a violation of the law. Nearly 60% of fire deaths are not in the room of the fire's origin, and 3/4 of all fire deaths are caused by smoke. When there are through penetrations in walls and floors, toxic smoke easily spreads to adjacent rooms. The keys to effective fire protection are both active protection, such as detectors and sprinklers, but also passive protection. Passive means that penetrations in walls and floors have been sealed with approved firestop products. This principle is called compartmentation. When installed correctly, fire and smoke won't be able to spread from one compartment to another. This allows for safe evacuation of people and protects valuable assets. The thing about compartmentation and fire protection is it's only as good as the products you use. And one always thinks that accidents only happen to other people. That's a false conclusion. It is the responsibility of architects, planners, engineers, and building owners to protect lives and assets by effective and well-designed compartmentation.
Okay, good. Our video also just one more time re-emphasize what I just tried to explain. In terms of, it is a very good visual because you can see that how the fire is traveling. Okay, some of the opening you can't see it in your office because they are above the false ceiling. But actually, those opening, those holes, if we not seal them properly, in case of any fire happen, the smoke will travel first, and the next step would be, of course, heat will transfer. Okay, so Hilti actually is spending quite a lot of time to also develop similar content to try to tell the right story to the market. Okay, we need to pay attention. Even though in the cable industry, we know about cabling, but when we come to interface with the surface, with the wall, surface and wall, if they're interacting, so we need to do proper seal up. Depends on the requirement of the wall. So the next slide actually is a very good segue because we are jumping to certain point about, oh, so I know that I got some cable need to run through from the riser area to certain other rooms. So when I travel it, we can't avoid. There's a plan like this, like what I'm showing. There's always certain fire-rated barriers. So we need to understand what is the requirement of those barriers. Ask the right question to the builders, or ask the right question to your designer. What is the rating of the wall? Is it a fire wall? Is it a smoke wall, a smoke barrier, etc., etc.? So this is a floor plan like a typical hospital project. As you can see, the red line is talking about exit wood, primary excavation wood, and blue line is another exit wood. So basically, you can imagine that if they are exit wood, all along those exit wood, all the area, all the wall, they all already need to be protected. They are all fire rated wall. Fire rated wall, fire barrier wall, shaft wall, fire partition. Those terminology, when you heard about it, basically it means that that wall, you need to provide a fire stopping material when you pass through it. Okay, because some people may challenge, okay, my cable just go through a normal partition wall. Okay, for that cases, you may or may not require to do fire stop. It really depends on what is the wall requirement. If the wall, when they design, it is a fire partition rather than normal partition, you need to handle it. I give an example. If we think about our unit where we live normally, a 2-bedroom unit, basically all the inside the unit, all those wall between the bedroom and the living room, those walls not typically they are not fire rated. But when it comes to between your unit and someone else's unit next to it, that interdependence wall normally they are fire wall. So this is something we need to be clear and understand the actual requirement. And smoke wall is also quite confusing. Currently in Australia building code, the smoke requirement is not very clear. Okay, I heard a lot of time in hospital project or some certain project they request smoke wall, but smoke wall is not a very clear defined wall type, unless they talk about smoke barrier. Smoke barrier is relatively well defined. Basically, smoke barrier is mean the wall need to be fire rated and also smoke seal, taking the two requirement. But smoke wall, from what I know, is currently in Australian market, it is unclear. Normally, people see smoke wall just required smoke seal, okay, not really fire rated. And we also have certain additional research done in terms of airflow containment. Okay, we will talk a bit more in the part 2 presentation, but at least you know that actually there's a certain standard and also certain requirement of what would be the air leakage we need to control, especially when we design high requirement project like a hospital and data center. And also, as you can see in the IBC building code in American, they also define that what is the size of the smoke barrier. And the smoke barrier also linked to what is the related flow rate to reduce the air leakage go through it. But this part we will cover a bit more in the part 2 presentation when we talk about mission critical facility. Okay, so this will be a relatively indirect part. Because I will use some real example to demonstrate what is the approach in terms of principle. Okay, when I need to have an opening, my cable need to go through certain wall. What will be the step-by-step approach to design a penetration seal? Again, I not recommend break and fix it. I recommend proper design, because we need to do the right thing. Otherwise, it would highly likely become a defect after a few months' time. So the exercise is there's a real scenario. Okay, so if something come up like when you're doing design work or when you're in construction phases, I have a 2 double layer cable tray. It's about to go through this kind of a concrete wall, and I'm working in a hospital project. This is a hospital project. So what would be the best product to use it? What is the step-by-step approach to identify the right product? Okay, in this scenario. And the assumption is this is a cable tray, go through 2-hour fire-rated concrete wall assembly. So let's jump to the details. First of all, I want to pull you guys think about, in the very beginning, what is the requirement by the code first, okay? To begin, let's adjusting any requirement by the code. We need to first explore what is applicable code we are using and what are the related test standard for the system. So basically, the ICC, International Code Council, they publish International Building Code, which is used in America to regulate it, need to be firestop. The Middle One Building Regulation 1992 is from New Zealand. New Zealand also have their own building regulation, talk about firestop is needed. Okay, and in Australia, we are following, we call NCC. NCC is published by Australian Building Code Board, ABCB. Okay, they published the NCC, and those code they require that we need to do firestop. Basically, at very high level. Okay, it won't tell you that what is the actual product to be used, but it tell you the requirement. And in Australia code, we would take Australia NCC code as an example to draw a little bit deeper to understand how should we read certain code. Okay, those building code they are very like long and complicated, but I highlight a few codes we need to pay attention, and those are the codes normally when we're having a project. This is the code the builder will refer to. It is those codes the certifier will refer to. Okay, from the NCC code, also known as BCA, Building Code of Australia. In the volume 1, 3.15, as we can see in this slide, when an electric or electronic services penetrate a building element, that is required to have an FRL. That installation must comply with one of the following. Basically, just as I described, if you have a fire-rated barrier FRL element, and there's any just go through it, you need to provide a system to cover this. And one terminology commonly used, especially in Australia, is people use a lot of tester system. Okay, tester system has been tested or assessed in accordance to the AS 4072 Part 1 and AS 1530 Part 4 and achieved the required FRL. Basically, we need to identify, I need to find a tester system as per these two standards can cover my application. Double layer cable tray go through a concrete wall. This is the firestop requirement from the code perspective, and it has specified which standard we should follow. Similar to other international standards, they always talk about we need firestop, which standard we should follow. And what would be the FRL requirement of my case? Okay, just assuming that we want to know more about it. Okay, normally we can just ask the builder, we can just ask the designer. But as an engineer or as a professional contractor or designer, I think we should also understand the code a bit better to know that what is the actual FRL requirement in my wall. Okay, as I outlined, we are having a hospital project, right? So basically in Australia NCC code, again, similar to other building code across the world. So it would mention that what is the required rating. Using our example, we need to check a few things before confirm the rating. The type of construction, okay? In the table C 1.1, there's a different type of construction called ABC type of construction, but they are linked to how big is the project. For example, it linked to the classification and also how many story of the building. So let's tangible our example, assuming that our hospital is a 5-story height hospital project. Basically, we know that all the building higher than 5-story, they are classified as class type A construction, And if we need to check the class of the building, it can be found in A6. There's a 10 different type, 10 different class of building, and healthcare building is classified as class 9. So basically, we know we have a class 9 building, and also the construction type is type A construction and class 9 building. If we know that, we know this is A construction, basically we can jump to check the building element, which is the next line. Depending on, this is a table showing that type A construction. Type A construction, we know that we are class 9 as a healthcare project. Different building element, they have different required rating. Depends on, is it load bearing? Is it a floor or wall? For our case, because we are non-load bearing internal wall. So you know that the FRL rating for our scenario, type A construction, class 9 building, it will be stage 120, 120. Okay, basically that's I try to summarize that 2-3 course. When we link them together, we will manage to find out what is the FRL rating for that wall. It could happen that a lot of the project, especially like hospital or data center project that we are always work in, they may using high rated wall, but the actual building code rating is actually lower. I was involved in a data center like a few months ago. Initially, the wall element they design and they use is a so-called like a 240 wall. But when we drill down to that internal barrier, internal non-load bearing, do we need to also give 4-hour rated 240 penetration firestop solution? It may not need it. So that's the point. Also, we need to know that how to find out the actual FRL rating. As you can see from these summary pages, actually not much of area we need too high rating. Okay, it is also driven by supplier, because in reality, to have a tested system to achieve 240, it is not that common and not that easy. We do have some cases, for example, on the top right bottom corner, about the type 7B and 8, they are talking about car park and garage. Those areas that the requirement will be higher and may need it in the floor case and some wall case, we need higher rating. But normally 120 would be the majority of case. And hopefully right now we all know that where can we find out, how can we locate the FRL requirement. Okay. So after we know the FRL, this is also linked to the standard. Okay, we know that the code required firestop to be decided and installed as per a tested standard. In Australia and New Zealand, we are using AS-based standard, AS 1530, AS 4072 to our AS standard. In other area of the world like Europe or other country or other area, they have their own testing standard. Okay, depending on the country, they also have different reporting format. Okay, for example, in Australia, we're normally using the bottom reporting format. We use report. We use tested system report, and the report is comprehensively telling every details. How should install, what is the coverage of this report, and the designer need to follow this to specify or install the material. And in Europe, they are using different approval for kind of a layout they call ETA, European Technical Approval. And in American, they're using certain listing, UL listing, like 2-page only, but only specific for certain application. And be aware that when we select or specify a product, those products need to be tested as per the standard, and the test lab need to be accredited. Okay? Because if lab is not accredited, we can't recognize it. Okay, I can open a lab using a small furnace, test something, issue a report, but that report may not be recognized because my lab and my knowledge haven't been accredited by the accreditators. In Australia, we have NATA, and in New Zealand, we have JASN, JASANZ. Those two parties are the accredited. If you receive report, I think you should able to locate their logo, sort of standing on some lab report, and those reports they are recognized. The importance of recognized lab is also related to data transfer, because if the testing is done in the accredited institution or laboratory, basically we can use the mutual recognition agreement to transfer to other lab or transfer to other country based on the MRA, mutual recognition agreement. Okay, so because as a global firestoping supplier, if you are designing a job for like a American embassy, sort of, okay, so you may need to follow AS American standard. If you are doing a job in overseas in another country, you need to follow that country standard. So in Australia, that we are using AS, as I described, same for New Zealand. And this also as an overview, actually Hilti with a pretty good knowledge and coverage in all the standard across the world. And we also find out that the Australia standard, AS standard, they are very, very similar to European and British standard. That's why in a lot of cases, we will also carry on to bring some European test data to this market. And to go to a bit more details, as you can see, both EN and AS standard, we are both measuring as per the integrity and insulation, and same oven pressure, and also very similar in general. Yeah. We have been keep talking about FRL rating. I think it is also worth to have a slide to explain clearly what is FRL. FRL means fire resistant level. Okay, the first digit is referred to structural adequacy. Structural adequacy. Talk about the wall, can it take loading? Second number refer to the integrity. Integrity is talk about the frame and the hot gases. Would it pass through the barrier? And the third one is about insulation. Insulation is about temperature. We need to make sure that the fire side and non-fire side, there's no heat transfer or only have limited heat transfer. Okay. Among all those criteria, it depends on what element we are talking about. Normal fire stopping penetration, we only refer to integrity and insulation. And among these two, actually, insulation is normally the criteria quite hard to fulfill. Okay, because we are talking about on one side, the furnace fire source having 1800 degrees C, the other side need to be within 180. So as you can see, the huge temperature difference, it is not always easier to manage. And the final interpretation will be FRL /120 120 or /240 120. Yeah. Okay. So I have a very interesting and very informative video talking about fire testing. Okay, basically these four photos show a little bit. Basically, fire testing is really build an assembly with the wall, with the penetration material, with the surfaces. As you can see, the top left photo, we have some piping cable tray and put into the furnace and burn it. Okay, and inside temperature is galvanized by ISO fire curve, super high temperature. Okay, and after that, we need to measure the non-fire side to see the temperatures, to see any integrity failure, insulation failure. For American standard, third box is about as whole stream testing. Only apply in UL related standard. They will even have hose really having high pressure water to test under the thermal shock. Will the fire stop material still stay in the wall? Yeah. So I think it will be better to show in a video, which is the next slide. Basically, this video is showing that how we set up the specimen and how we bring it to the accredited testing facility and burn it. Yeah. Set up the temperatures, as you can see the fire starter. This is inside the furnace. We need to maintain the furnace pressure and temperatures as per the standard. Basically, all the surfaces, even it is a cable. I burned a few times in Melbourne last year. Basically, we can't see any cable left in the furnace. They will totally burn away. And the time is actually talk about the 60 minutes, 120 minutes related to the FRL rating. This is the whole stream one, pretty impressive. And as you can see, a lot of the why we need intramanson type of material, you can tell, because the intramanson material, they will expand, form of like a foam chart, carbon chart, to prevent the heat grow through it. And as you can see, this pipe ring, initially they have a pipe, but after the burn, the pipe totally gone. Okay, and it become like a lot of intramanson material kind of blocking the opening. Yeah. And for cable, it depends. For some big power cable, after the burn, it will still stay there, but there's already a lot of small gap here near the wall. So therefore, intramanson masking is also required to seal all those gaps. Yeah. Fire testing is a very extensive and intense process. Okay, so after we do the test, we can have the reports to support. For that application, this solution can provide the rating. Okay, so it is not only about any chemical can be especially I heard about a lot of people challenging mastic. Any student can be fire rated, but it is not the case. We need to pass through certain very extreme testing in order to have accreditation and the report. Another quick quiz, I would say. So I think we know the code requirement as well as the testing procedure. The idea is, if someone asks you, it is a question a lot of people ask me. They ask me, Rick, this fire-stopping muffin, fire-stopping plug, what is the rating of this fire-rated plug? Okay, I have been asked by unlimited people in all level. It's about similar question. Can your mastic be 2-hour rated? What's the rating of your pillows or of your muffin? So it is a tricky question. So the typical answer, I guess, is people will say, I know that this is a 2-hour material or 4-hour 240 rated material. However, the reality is there's no rating for the material itself. No individual firestop product from any manufacturer carry a fire rating. Only an entire firestop system is rated. Okay. The answer should be, if the similar muffin install 2-layer, okay, go through the concrete wall, and then apply the bandage on top, and then the cable size is also compliant, it is a 2-hour rated 120 system. Okay, so this is a very important concept. Don't think about just product, always come from the application base or as a system. Using the terminology in the NCC, tester system, right? This is a tester system. Material itself is not a tester system. I try to structure a little bit. Okay, that's too complicated. So in reality, what we need to consider, if we are not thinking about product, what are the several components of firestop system that will impact the performance? First of all, we need to understand the desired FRL. We've gone through the NCC together. We know how to find FRL. Of course, we can also ask the builder, ask the designer, and they are in minutes rating in Australia. The type of construction and thickness, which is the second one, substrate. Okay, what are the type of construction? Okay, is it a plasterboard wall, or boardwork wall, or concrete wall? And then we need to understand the orientation and the size. Pay attention on the size of the opening. A lot of cases, people may think about, oh, I got a 16mm cable. Let's do an 18mm hole. Perfect. But later stage, they find out, unfortunately, the tester system requests a bigger opening, because my system is using inch-dimension mastic in the apertures, in the annular gaps. So end up the opening is not correct. They need to do it again. It is easy for single opening, single cable, but when it's a cable tray, big opening, concrete opening, it is not that easy. So even the opening size, orientation, it is important second step. And the third one is about the size and type of the penetration item. Okay, this is talking about the diameters of the surfaces, size of the cable tray, cables, and etc. etc. Okay. Today I may not have time to go too details in terms of cables, but those are the level of details we need to consider, or we need to check with the related firestop supplier to confirm they can help us. And at the same pages, we need to check the annular gap. We already explained, linked to the previous block. We need to check that what annular gap we need to do. Some system, we also need to check the percentage of cable fill. Some system can only support you to fill, like the previous muffin example, we support you to have like a 60% cable in the open. If the cable area is bigger than 60%, basically the opening is too small, or you need to find some other solution. So additionally, we also have certain additional attributes requirement, talking about cable repenetration, acoustic requirement, water movement, aging, airflow control, air containment control, that sort of things. But those additional things, I would leave it to the next wave of presentation. But it depends. If we are working in super high-end requirement project, always those requirements become equally important as firestop. But as a tester system, actually, all of the points need to be balanced, and then we can link to the solution or the product. Basically, this is the report outcome after all the testing, after all the consideration. As you can see that we will have like a report in Australia standard. It is a report talk about the test system, and it will refer to what is the rating, FLL rating in the middle part. And in most of the case, we will also provide certain drawing to introduce, okay, this device can be used for plasterboard, what thickness it should be, or is it also applied for concrete, and etc. etc. Okay, let's go back to the exercise. Okay, we spending maybe around 35 minutes to go through the requirement, but end up we just want to seal the opening. Okay, so this opening we need to go through all the process. So basically we need to check the report. Okay, here for example, like Hilti provide a report talking about, okay, Hilti, we got a fire rated block solution, and from the left hand side you can see that it highlighted what wall we tested: rigid wall, which is including concrete, and also plasterboard. Rigid wall, take the first part, check the wall material, and then we also check the cable sizes. Distance requirement, okay, we haven't touched on that, but actually in the approval document we also mentioned cable tray. Between the tray, what should be the separation? What is the bundle sizes maximum limit, and etc. etc. After go through all the things, actually we find out, okay, this is a right solution can be used. So in conclusion, okay, the last part is talking about the differences in between typical and some innovative solution in cable penetration. As I showing that in the slide, we discussed the minimum or basic firestop code compliant. This typically involve we call traditional method, using the products such as sealant or pillows or bed system. There's an advantage and disadvantage. The advantage is relatively they are economical. They have coverage on multiple applications. But the disadvantage, another way around, would be they may not able to do any repenetration in the futures, especially when we talk about ICT infrastructure. We need to have certain flexibility for futures, like the photo on the floor penetration. There's a cable bundle go through the bottom part. You see some blue part. Actually, they are pillow with mastic. For those solutions, it is almost impossible to do repenetration unless we redo the all penetration once. So those are the limitations, and the installation is also complex. They have a lot of requirement in terms of applying mastic around the cable wrap, etc. etc. So the correct installation is varies by installer. And a lot of system, including the wrap system and also the bed system above, they're all having some fibers. When we are working in certain high requirement project, they require the clean room. Basically, fibers is not an ideal material. Imagine that whenever we need to add cable, change cable, we need to cut the fibers, and then the dust come out, and all the dust is very sensitive in the data center project or clean room related project. Yeah. And the relatively kind of a innovative and also preformed devices is about what I'm showing. Actually, Hilti, most of the solution we decided, cable need to be repenetrate, so the material need to be flexible and cater the movement in case any surface need to move in the futures. And apart from like the repenetration, the system also allowed more easier to install, especially the bottom ones. You can see that there's some devices you can open and close. When you install this device in the wall or floor, you can have unlimited repenetration, very easy. You just need to twist the red part in the photo and you can get it done. Yeah. So of course, we haven't focused yet, but the preformed innovative solution can also fulfill certain airflow control performance over the traditional method, which we will explain a bit more in the part 2 presentation. And as for designer point of view, all those preformed devices are also easier and can be seamless to be modeling in the BIM model, building information modeling design. Basically, you can really design properly rather than just break and fix it, right? So sorry, Paul, I still keep using your example. And last but not least, I just want to have a quick review what we've gone through. We've gone through about the code requirement and the test standard for the fire barrier. We know what does FRL stand for. Okay, we know the importance apart from fire, we also need to pay attention on smoke travel. Then we briefly mentioned air rating. And we also emphasize, especially in Australia and New Zealand market, we always refer to tester system. And tester system is not product-based. It is application-based. Okay, we also review the test report. For you, actually, all the installation detail, it can be found. So I think I just want to re-emphasize, to do proper fire stopping, it sounds like complicated, but when you know the principle and concept, it can be done easily. And the point is, just don't randomly grab any fire-rated mastic or fire-rated material. Request a proper report, check the details if you can manage before you even drill a hole. Check the detail first. Okay, it can save you money. It can save a lot of time in terms of fixing back and forth. Okay, hopefully you will know after the presentation. Hopefully you will know the principle and guideline about fire stopping on penetration design for the ICT infrastructure. So I think it is come to the end of my presentation. And if there's any question, please feel free to put it into the Q&A board, and I will also try to call Paul back to help me running the Q&A part. And this is my info. Please feel free to contact me by email, phone numbers. And Hilti also have a technical engineering team. We receive normal inquiry, which is another email address. So basically, you can send to myself, or if you want to just a general consultation, you can also reach out to the AU Technical Center at hilti.com. Yeah.
Many thanks for that, Rick. Certainly appreciated that, stepping us through the principles of fire protection, and of course the important aspect of how us in the ICT infrastructure area can administer it and how it affects us. I understand that there are maybe some questions coming on board. I should have actually mentioned at the introduction that you can use the Q&A board. So if you do have any questions over the next 5 to 10, 15 minutes or so for Rick, please use the Q&A board. We'll try and aggregate those and we'll just read them out and just step through it. Whilst you're thinking about that, what I'd like to do, Rick, is if I can throw a question at you,
Yep.
and this has been something I've been, I guess, met with in our discussion in the Cabling Standards Committee. Once a fire-rated collar or system has been put in place, it's tested, etc., what labelling is required, or what happens after it? Does it require to be certified, labelled, information passed on to the building owner? What's the responsibility after that?
Yep, this is a very good question. Thank you, Paul. So in Australia standard, in the AS 4072 Part 1, there's a certain course talk about how we do documentation about surface penetration. Okay, they use documentation rather than just labeling, because it is include labeling as part of the documentation. Basically, we need to in that section, it mentioned we need to have a label mentioning that what is the FRL rating, what is the material you install, who installing, when installing it. So stick next to the penetration and take a pictures, and all those photo record need to be submitted to a certifier. And it is worth to note that similar documentation requirement in the standard is recommended approach, not as a mandated approach. But I also are highly aware that there's a more and more builders certifier, they request, please proper penetration register. Tell me what you has been installed, because they really find too many defects. Those defects may be identified in the before the occupation certificate, before the OC. Some of them actually they find out after this. Even the council inspector come, they find out, oh, this penetration seems wrong, and end up have a lot of problem. So if we can manage, try to keep proper recording of what we install, put a label next to it, and of course, you need to install as per the report. So, and you can submit the package with the register and the report to the certified and builders. It is getting quite common and hot in Australian market. So, and of course, in the market, there's a different software tools can help you to do this documentation. Maybe I can also include a brief explanation in the next part, because Hilti also have a software called Hilti Documentation Managers. Feel free to Google it, have a look what is it, and it is exactly talking about how we record the penetration. Yeah.
Okay, thank you very much for that, Rick. We've just received a question from Kerry Meredith. I'll just read it out. Are there restrictions in the Australian Building Code to not run particular jacket types through passive fire protection devices, e.g. polyethylene?
Jacket type. Okay.
So the cabling has different jackets, a classic case of PVC or polyethylene. Are you aware of anything in that particular space?
It is quite linked to test standard. Okay. I would say that in Australia standard, there's a certain guideline for us to test cable. They call D1, D2 standard configuration. And in those standard configuration, it covers PVC insulated and also XLP insulated cable. For other cable like polyethylene or others, it is not currently covered. So basically, the certifier and the builder, they have the right to question, okay, for this type of cable, we need to conduct separate testing. So basically, the building haven't limited it, but it will link to when you find a fire stopping solution, it will become an issue because the cable you're using the jacket is a special insulation rather than typical PVC and XLPE. So it would have a big problem. I think this is also a challenge for cable manufacturer. Okay, so they also need to check that when they launch the new cables, need to be already covered, or if it's not covered, there's some exercise, fire stopping supply and those cable supplier, or even if you have from a contractor point of view, you already install it, it could end up to doing certain assessment or need to do a small fire testing to verify for this jacket what will be the impact. But from what I reckon, I don't see this bending this, but because if you use this, it will have problem in terms of fire stop. That's why maybe some of the designer and builder, they will recommend, let's don't use something out of the typical material, because when we talk about tested system, it is actually really go down to type of cables. Yep.
Okay, good. Thanks very much for that, Rick. Look, I know in my own experience with the S008 Cabling Standards Committee, there were issues about jacketing systems or outdoor cabling that had water repelling systems that have flammable properties. A classic situation of rodent resistant or bug resistant cabling with nylon 12 jacketing. They are given to giving off a lot of smoke and fire. So it does bring up some interesting points. So we have addressed it to a limited capacity within the S008 document, which is that for product that manufacturers would need to adhere to. But it does create some very good discussion. So thank you very much for that, Kerry. It's an important point. We'll perhaps take that offline and see if we can get some more answers for you. Do we have any other questions at all from the audience? Okay, I'm not sure if anyone's typing at all. It might take a little bit of time to type up a question. Basically, what we'll do is we'll look at closing up the presentation soon, and unless there's any more questions. So first, I'd like to thank Rick and his team at Hilti for putting this presentation together. We did specifically request information pertinent to our industry. There's a lot of material that you covered, Rick, that was based on fire principles that we needed to understand in the first place, but you went to a great deal of effort to then tailor the presentation to our expectations, to what we need to know. I personally have found this an incredible journey of education, particularly from the S009 regulatory framework, what to do. What I have learned personally, and I wanted to convey this to everyone on this call as well, is that we are accountable if we put a penetration in a fire-rated wall or any barrier, be it a wall or floor that is deemed to be a fire containment service. Importantly, that we recognise the fact that we have to work within the building regulations as well. We're not independent of those building regulations. We are a service provider. We have issues that become apparent on site. They do pop up unexpectedly from time to time, particularly if you're doing services in an existing facility, whether it's designing or installing. We really need to make sure we need to where to go to for information, and that certainly I appreciate Rick's team putting some good information together for us. Just as an extension, I've also had extensive dialogue with the Fire Protection Association of Australia, and they've given us tremendous guidance from that perspective. So whilst they're not on this call, on this webinar, they're certainly appreciated for their input. Also, thanks to Fluke Networks for facilitating this webinar on their platform, on the WebEx platform. Certainly appreciate that. And thank you all for your participation and listening in. I see we've got a few thank yous coming through on the chat line. So thank you very much. Appreciate those comments. And as we said, in 4 weeks' time, we're going to have part 2 of this presentation. Hopefully Rick will be able to make himself available again to step us through the more intricate details associated with data centres and healthcare facilities, where it's not just a case of fire, but it's also smoke, and it's containing air movement, be they contaminants or diseases or whatever the case is. These are unique environments that we as ICT infrastructure folk will come across from time to time. So we encourage you to attend that as well, which will be a very informative session. It'll also give Rick a chance to do a deep dive into specific areas that he had to gloss over today. And also a reminder, in 2 weeks' time, our next webinar, we're going to draw the difference, both the legal and the practical differences between a safe work method statement and a job safety analysis, something that we all incur, but what are the legal ramifications of that? So we'll get an invitation to you about that shortly. So with that, we'll close, and thank you very much for your participation today. And from wherever you are, be it Australia, New Zealand, the US, or Japan. Thank you once again.
Thank you, everyone. Thank you. Yeah, see you soon.